All right, we're going to begin our lessons on matrices, plural of a matrix. A matrix is just a way to arrange some information. Again, as we get further into this, we'll realize how powerful matrices can be. And so it's really just a table, and we refer to matrices by their dimensions. So this has 2 rows by 3 columns. So it's a 2 by 3, row by column. And rows run across, and columns, if you think of the columns on a building, are vertical. So 2 by 3. And each individual cell is called an element. Like if this was in a spreadsheet, that would be a cell. So this is in row 1, column 3. And I'm going to use that later when we do matrix multiplication. Matrices are pretty straightforward. If I want to add one matrix to another, first of all, they have to have the same dimensions because everybody needs a partner. If I have an A here, I need something in the same element to add to it. So A plus E would then just go there. B plus F would go there. C plus G, etc. And the same is true for subtraction. A minus E goes in that cell. Row 1, column 1 minus row 1, column 1 goes in row 1, column 1. And so you'll be asked things like perform the operation if possible. So if the dimensions are not the same, you can't do it. Actually, just to be clear, this should go pretty quickly. So 3.5 basic matrix operations. I'm just going to ask you to do all of it. The other thing that can happen in a matrix is we do what's called scalar multiplication. That is essentially just multiplying everything in the matrix by a single number. You'll see later also in geometry how we deal with dilations. So negative 2 times 4 is just negative 8. Negative 2 times 1 is just negative 2. And negative 2 times 2 is negative 4. Pretty straightforward. And then order of operation sort of applies too. If I have 4 times matrix A plus matrix B, I'm going to do my multiplication first. So in this case, I'm going to scalar multiply matrix A, get that, then go ahead and add it to matrix B. And since they're the same dimensions, we can progress. So these properties are the same. We have the associative property, which means I can group in whatever order I want. If I'm adding 3 matrices, I can add whichever 2 are convenient. Again, they have to have the same dimensions. Commutative means I can add in whatever order. Distributive property, if in this case I can distribute. If I had 4 times matrix A plus matrix B. Remember up here, 4 was just being multiplied by matrix A, and then I was adding to matrix B. But if both matrices are being multiplied by 4, and again, you could actually do that in whatever order you wanted. You could add those 2 and then multiply by 4, or you could distribute. Whatever turns out to be easiest. So I think you'll be able to do the addition and subtraction and all of that pretty easily. Make sure basically they have to have the same elements in order to perform the operation. If not possible, it's because the dimensions are not the same. And remember, it's row by column. They have to match. Then down here you have some scalar multiplication. You can handle that. Here's some of the fun stuff. We throw some variables in there, so I'm going to show you how to do those. And then finally, this is just in our simplified world of Algebra 2, sometimes I feel like the word problems are kind of convoluted or really made up, but this is a pretty good practice in just trying to read charts. And I went through it. I think it's pretty self-explanatory. I think you guys can handle it. It's about, locating something. You purchased book A in 2002. Okay, so here's 2002, here's book A, here's how much it cost, right? So I think you guys can sort the answers to these questions out. And of course, you have the answers so you can check. But let's go back to what do I do when I have a problem like this? So here's one. And here's how I like to do it. I like to think about the whole, so if I'm looking for x, what's the relationship here with x? Well, when I took negative 2x and I added it to 2 times 5, I got negative 9. So there's my relationship for x. I'm pretty sure you guys can isolate x at this point and figure out what it is. And then here's my y down here. Well, where did that come from? It's in row 2, column 2. So I started with negative 8. I added 2 times row 2, column 2, 2 times 6, and I got y. So I just think about the order, where it came from. What is the relationship that involved x or y? So hopefully that helps you out with that. Again, there's always a bunch of ways to go about doing it. That's how I would do it. So yeah, that should be a nice little reprieve for your brain after systems of equations in 3 variables and graphing inequalities, and you find out matrices